We start off with our piece of virgin white paper. We take out the box. Now, this paper is coated with a silver halide, and it's light sensitive. Okay? Now, a silver halide consists of silver, metallic silver, coupled to a halide. Now, a halide, there are 4 halides in the halide group. There's bromide, iodide, chloride, and fluoride. Okay, that is the family of halides. Fluoride is water-soluble, so it's not used in the photographic industry. It's put in water, toothpaste, things like this for reasons you know. So that leaves us with 3. I'll just refer generically to silver bromide, just for ease, but it could actually be any of these. Silver bromide is what was used in the cold tone emulsions, silver bromide papers. They were known for their cold tone, their bigger grains, and they were much loved by photographers who liked particularly cold tone black and white prints. Silver chloride is a finer grain, and it's a very warm tone. And silver chloride papers were used by large format photographers for print and still are, if you can get them, for contact printing. Azo paper, for example, and Michael Smith's Azo replacement, these are chloride, silver chloride papers. Iodide is used by some manufacturers to put in the paper, but there is no single silver iodide paper, but it is used as a mix. And virtually every paper, I think there's only one silver bromide paper still made. All the others are a mix of silver chloride and silver bromide. And the ones that are predominantly silver bromide are often referred to as bromochloride papers and are cooler in tone. The ones referred to as chlorobromide, reflecting the fact that they have more chloride in than the bromochlorides, and they are warmer tone. And various papers employ a little bit of iodide to give the paper certain characteristics. Kentmere used to use iodide quite a bit in the papers as well. So that's the family of halides. I'll refer to them generically either as halide or bromide, just for simplicity. So your paper is coated with a silver halide, and it's light sensitive. So you take it out under the safe light. Okay, so this is in the dark. Okay, little moon. And it's a slightly wobbly moon. There's a cloud. And you project your image onto it, okay? And all being good photographers, of course, we like to photograph a tree. So we've got our little tree here. Now, we're advanced photographers, I'm sorry. We photograph a tree and a rock, okay? So there's our image. We can't see that, but the paper has changed because the silver halide on there has been activated by the light. And although we don't see it any different in the darkroom, this silver halide is now different to this one because it has been activated. So we take that and we then put that in a developer. And what happens here, see, this is all AgBr. Okay? Ag is silver, Br is bromide, which might be bromochloride, but we'll call it bromide. Now, we take it to the developer, and the developer splits these two, and our image appears, and we could see there's our tree and rock. And this is just silver now. This is actually silver metal, little grains of metallic silver, black metallic silver, which we see as black, greys, according to how much there is, or white, where there is none. And this is in the developer, so it's still in the dark. It's still light sensitive because it still has got silver bromide, bromochloride, in all the areas that the developer hasn't converted to an image. That is all the whites, all the borders, the white backgrounds. It's all still there, and it's light sensitive. So to make it light stable, we have to put it in the fix, and the fix converts everything to plain metallic silver, and the bromide bubbles off into solution, and from here, and the silver that's been unexposed also goes away. So we're just left with silver and nothing else on the paper. So at this point, we can put the lights on and we can look at it. And from here on, what we do today is all in the light. So this is very, very simplified, okay? You could pick the holes in it, but this just gives you a basic understanding of what's happening. And of course, we now know from our lith experiments that bromide builds up in the lith developer. It's a restrainer. It changes the action of the lith developer, and it changes the colors you see on the paper and so on. So this is where it comes from. Now, this is the end of the process, right? No, not necessarily. We're going to find today that there's a whole big world on this side of the board in the light that you can start to explore. And the first thing we'll do is we'll take a bleach, or a reducer as it's sometimes called, and we'll put that print in the reducer. The commonest reducer is ferricyanide, and it reduces the silver to a near colorless, slightly faint biscuit color image. So it's no longer black silver, it's a pale silver ferrocyanide. Okay, so the silver is still there, it's in a different form. If we add, we call that ferri, because Fe is iron, and there's nothing to do with this, we'll call that ferri. If we add a halide to that, ferri and bromide together in the bleach mix, what we do is we now convert this back to a silver halide from the silver ferrocyanide, just where the image is. Nothing anywhere else. All the other silver halide has gone away in the fix. The white borders, the white backgrounds, the highlights, they're just plain empty gelatin. So we just have our image here, and it's now in a, it's still light sensitive, but it's not very light sensitive, and we can easily work in room light and watch it. If you take it into strong sunlight and do it, you will get some printing out taking place that you could see it will change. But it's much less light sensitive. So we now have this. So we're sort of more or less back to where we started, back to our piece of paper, with the exception that it only is where the image is and nowhere else. So what can we do with this? Well, we could do all sorts of things. If we can redevelop this. We can put it back in developer again, okay? And we can then convert it back to silver. And we have our silver. Well, what's the point of doing that? We already have that. You don't have to use the same developer. Okay? You could use a cold tone developer and bring it back with a colder tone. Or you could use a warm tone developer. Okay, so developer, so it could be cold, it could be warm, it could be soft contrast developer, or you could put it in a high contrast developer. High. Okay, so you could have a second thoughts about your picture and reinterpret it. Make it warmer, colder, change the contrast. You could put it in a list developer. Now, this is fun, and you'll get a list print coming back. Okay, so we'll put lith. So you could get the list print coming back. The list print you get here may vary considerably from the list print you would get from that paper if you list printed it conventionally. At this point, you could start with a black and white print, or you could start with a lith print. Ideally, because, as you know, with a lith development, you never take it to completion. So ideally, you snatch it partway through, so you're not redeveloping all the silver, so it will always come out paler. So you ideally start with a print which is a little bit too dark. And if you snatch it very early, you'll lose a lot of tones, so you need to start with a print which is a bit more dark. If you snatch it very late, you'll only lose a little density, so you need a print which is just a little bit too dark. So I'm telling you exactly how dark it needs to be Depends on how you want to interpret it. But you'll discover this, and I think many of you may have prints of varying densities, so you'll be able to play with that. You'll have options. These you will all take to completion, you see, so you take everything back to where it was. With lith, we never develop to completion, do we? We snatch it at a certain point for all sorts of reasons. For the small grain, large grain mixture, warm, hard, soft, cold, grainy, grainless. You know all the characteristics now. So we stop it part way through. So we can redevelop it in lith. And this has a whole new life. We can do other things. We can take a different bleach. This is our ferrocyanide bleach. We're going to also play here with a copper bleach. Sorry, that should have gone up there. Whoops. Quick editing. Okay, so we could go for a copper bleach. And this puts copper into the paper and gives you totally different properties. This process actually sort of creates your new emulsion for you. So if you started with a paper like many resin-coated papers that contains a developer accelerator or a developer to make it come up really fast, many of these will not lith print, because to lith print, the lith developers, as you know, only have to have only hydroquinone as a developing agent, because that's what gives you this infectious development pathway. If you have another developing agent in there, it doesn't work. It just takes over. So once we've developed one of those resin papers or one of these unsuitable papers, or a suitable paper that doesn't happen to lith print very well, we end up just with a silver image. Now we can bleach that and create our new silver halide. And then most of these will lith print. So this expands our range of lith printable papers far beyond what is suitable for what I call first pass lith, which is just one pass lith, if you like, just one pass through a developer. I call this second pass lith because it goes, the first pass is through another developer, the second pass is through a lith developer. So that's my term just to distinguish it from other forms of redevelopment. And then you could start again, and you could take it in different directions. You could take it to a sepia toner, and of course this is how sepia toners work. And that image will come back in sepia. Sepia. Now, if you were to do this, these bleaches, this bleach, I should say, starts working just in the light tones, and it bleaches away the light tones, and then it moves down to the middle tones, and the blacks cling on to the last bit. And so with some papers, they are very slow to go, and eventually the blacks will go. You can decide whether you want to just take it for the bleach really early if you're sepia toning, and just put a little bit of sepia just in the highlights. Because if you bleach it a little bit and put it in a sepia toner, the toner will only work where the bleach is bleached. It won't touch the rest, which is just black metallic silver. So you could just have the highlights bleached, or you could bleach all of it but just keep the blacks black, or you can bleach it all and then the blacks will come back in a sepia brown as well. So you have a lot of options. But this is the pathway for sepia toning, and that uses this bleach. So we've come down this pathway, ignoring the sepia one for a moment and ignoring this. This is the pathway we're going to explore today, okay? So we'll just separate this bit off because that's another workshop area. We're coming down here to lith. So we now have a lith print. Perhaps a very different lith print, as you'll see. But it's still silver. It's still metallic silver. And because it's metallic silver, we can tone it just as we could tone a straightforward print or a straightforward lith print. So we can then take this on, and we could take this into gold, which is AU. We could take it into selenium, which we'll call SE. We could take it into all sorts of other toners, sepia, iron, copper. Look through the toning book. There's a whole book full to choose from. So this is, again, a whole new pathway to explore. So this isn't the end of the journey either. So when you have your black and white print, actually you're just at the threshold of a huge field of opportunities of personal expression. You're just on the start of a journey if you want to take it. And you can see what's going on because you do it all in the light, and this is nice.